All right, let's talk about one of the most powerful and maybe a little mysterious technologies out there today: machine learning. Seriously, it's the secret sauce behind why your apps and websites seem to know exactly what you want, sometimes even before you do. We're going to pull back the curtain and see how it all works.
I mean, you've totally felt this, right? You finish binge watching a show, and boom, Netflix serves up your next obsession. Or you're about to head out, and your map app is already telling you, hey, you might want to avoid this street. It feels kind of like magic, doesn't it? But it's not a magic trick. It's technology.
And yeah, the answer is machine learning. It is the engine running in the background of so many things we just take for granted. We're talking about everything from how your social media feed is built to how your bank can spot a weird charge on your card in seconds. It's everywhere.
So what is this thing really? Well, you can think of artificial intelligence, or AI, as this huge, big picture idea of making machines smart. And inside that big idea, machine learning is one of its star pupils. It's a specific, really powerful way to achieve that intelligence. Okay, here's the absolute key takeaway. For decades, we had to give computers super detailed step-by-step instructions for everything. But with machine learning, we kind of flip that on its head. Instead of giving it rules, we just dump a whole lot of data on it and say, here, you figure out the patterns. It's not about being told what to do, it's about learning from experience.
So how in the world does a machine learn? Well, it all starts with building what's called a model. And luckily for us, there's a really simple classic recipe that breaks down exactly what you need. Now, I know this looks a little dense, a bit academic, but trust me, this quote from a pioneer in the field, Tom Mitchell, is actually a beautiful and simple formula. He basically gave us the 3 key ingredients for teaching a machine anything. And it all boils down to this: T, E, and P. First, you need a task, the T. What job do you want it to do? Let's say spotting spam emails. Then you give it experience, the E. This is just tons and tons of data, thousands of emails, some spam, some not. And finally, you have to measure its performance, the P. How good is it getting? If its spam catching percentage goes up the more emails it sees, well, congratulations, your machine is officially learning.
Okay, so we've got the basic recipe. Now let's talk about the different cooking styles. You'll find there are really 3 main ways that machines learn, and you can think of them as learning with a teacher, acting like a detective, or being trained like an athlete.
And those 3 styles, they map directly onto the main branches you see here: supervised, unsupervised, and reinforcement learning. So let's break them down, starting with the one you probably interact with the most. First up, supervised learning. This is our teacher model. Imagine you're giving a computer a giant stack of flashcards. On each card is a picture of an animal, and it's already labeled, this is an elephant, this is a camel. The whole point is for the machine to learn the patterns from these already answered examples, so that later, when it sees a brand new picture, it knows what it is. It's literally learning with an answer key. But what if you don't have an answer key? Well, that's where unsupervised learning comes in. This is our detective. This time, you just hand the computer a giant, messy pile of data with 0 labels, just a folder full of animal pictures. The machine's job is to play detective, to look for clues, find connections, and sort that messy pile into its own logical groups. It's all about discovering hidden patterns all by itself. And finally, we've got reinforcement learning. This is our trainer. This method is all about learning through pure trial and error. You have a program called an agent, and it's trying to do something in a virtual environment, like win a game. When it makes a good move, it gets a reward, a point. When it makes a bad move, it gets a penalty. And over millions and millions of tries, it just figures out the best strategy to get the highest score. This is exactly how AI gets so good at complex games.
So, just to make it crystal clear, let's put the 2 most common types side by side. Supervised learning, our teacher, is task-driven. You have a clear question, like, is this a cat or a dog? And you use labeled data to get a defined answer. Unsupervised learning, our detective, is data-driven. You just have a pile of data and you ask, hey, are there any interesting groups or patterns in here?
Okay, so we know how they learn, but what kinds of puzzles are they actually solving with these methods? Well, 2 of the absolute biggest are classification, which is just a fancy word for sorting things, and prediction, which is all about forecasting a number. Here is a perfect classic example of classification. The machine is fed a bunch of data about flowers, their petal length, their width, and so on, and each one is already labeled with its correct species. The machine just chews on that data until it learns the patterns. Then, when you show it a new flower it's never seen before, it can accurately classify it. It's sorting things into the right buckets.
The other huge task is called regression. This is what you use when you're not sorting things, but trying to predict an actual number. The classic example? Predicting house prices. You feed a model data on thousands of old house sales. Square footage, number of bedrooms, location. And it learns the relationships to predict a specific price for a new house on the market.
Okay, that's enough theory. Let's bring this all back home, back to the real world, and see just how tangled up this technology is in our everyday lives. It's probably more than you think.
And look at that, we're right back where we started. That feeling of magic? It's all these models we've been talking about just humming away quietly in the background. Every time your map app reroutes you, every time you get a great recommendation, a machine learning model is doing the heavy lifting for you. And it gets even wilder. There's something called market basket analysis, which is famous for finding that people who buy diapers often buy beer, a weird but useful pattern for stores. We all know recommender systems, but it's also used for anomaly detection, which is how your bank flags fraud, and dynamic pricing, which is why ride-sharing prices can change minute by minute based on demand.
So when you really strip it all down, machine learning isn't some black box or magic spell. It's a powerful tool, for sure, but at its heart, it's just a way for computers to do something that feels incredibly human, to learn from experience, to spot patterns, and to get better over time.
And, that really leaves us with a massive question for the future. We've already taught machines how to drive cars, discover drugs, and beat the best players at the world's most complicated games. As they get better and better at learning, the question really isn't, can they learn something? It's, what's the next important thing we should teach them?